problem 3 on practice exam 10 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. I have a study of turtles, Atlantic origin loggerheads, and Mediterranean origin loggerheads in the Mediterranean Sea. Here's a graph of the curved carapace length in centimeters. The Atlantic origin is the dashed line, and the Mediterranean origin is the solid line. Part A, carefully estimate the growth rate of the curved carapace length for both Atlantic origin loggerhead and Mediterranean origin loggerhead at the age of 5 years. So right here, 5 years, right up there. What's the growth rate? The growth rate is the slope of those lines. So let's identify the points at 5 years. There they are. Then we draw good tangent lines. I'm going to use red because I don't want it to get confused with the Atlantic origin dashed line. So there's the slopes. And to get the rise over the run, we need some other lines. So let's add some lines to estimate values. There's some vertical lines. So the slope is the rise over the run for the Mediterranean. Mediterranean origin is the solid line. That's right here. The run's about 29 years, and the rise goes from 20 to 80 centimeters, 2.76 centimeters per year for the Mediterranean origin. The Atlantic origin, the rise is again 80 centimeters, and the run is longer. It's 35 years. So the slope is lower, and that's a significant difference. After 10 years, it's going to be a 5 centimeter difference. Part B, what's the difference in the growth rates at 10 years? We want the growth rates at 10 years. So let's identify the points. There they are, 1, 2. Draw the tangent lines a little bit closer. Let's add some lines so we can get the values. This one's even off the graph. So we got 100 minus about 24. That's 76 centimeters, and that goes over 33 years for the Mediterranean, 2.3 centimeters per year. And the Atlantic goes all the way over to roughly 42, and about 22 centimeters from 100, that's 78. So that's 1.86 centimeters per year. Closer, but the Mediterranean is still higher. Next is 20 years. What's the slope at 20 years? So we need slopes at 20 years. Let's identify the points. There they are. Sketch in the tangent lines. Those are pretty close. Let's add some lines so we can estimate the values. There's some vertical lines here. You can see this gap is bigger than this gap. So the Atlantic is actually steeper than the Mediterranean. So the growth rate's higher for the Atlantic here. Going to be really close. So I was very careful with these, measured this very carefully. That's 92.5. That's 37. So the rise is 55.5, and the run is 40 years for both of them. That's 1.39 centimeters per year. The Atlantic goes from 86.5 right here to 29 right here. That's the rise, and the run is the entire graph, 40 years, and that's a slope of 1.44 centimeters per year. So the Atlantic is actually a little bit higher, as we expected. On to part D, carefully estimate the difference in the CCL between the Atlantic loggerhead turtle and the Mediterranean loggerhead turtle at an age of 20 years. So what's the difference in the curved carapace length? So let's put some grid lines in there. There's 20 years. Now we got to go over to the vertical axis. Okay, so this one, Atlantic, about Mediterranean is 64. That's this one. Atlantic's about 58, right here. So finally, part E. Draw some conclusions regarding this difference. When does this difference happen? And it seems pretty clear that the reason why the Mediterranean origin loggerhead is bigger at 20 years because the growth rate is higher when it's young. This is where it gains the advantage. The growth rates here are very similar. The slope's very similar here. Here the slope is different. That's problem 3.